Good morning, everyone, and welcome to the rollout of the Orion Exploration Flight Test Article 1 behind me. This is a great day. I'm Dan Dumbacher in the NASA Human Exploration and Operations Mission Directorate. I'm the Deputy Associate Administrator for our exploration systems. This is truly a great day for all the progress that we have made and the Orion team has made on the hardware. This is our first step in exploration beyond low Earth orbit. A couple of weeks ago, we had a great success with the commercial activities in SpaceX going to the International Space Station. Behind me, you see the Exploration Flight Test Article 1 for Orion. This is our first step to go beyond low Earth orbit. The flight test article behind me will go through its flight test in 2014 in preparation for our next flight test with the all-up Space Launch System in 2017. I'd like to thank the Orion team for getting us to where we are today, the Kennedy Space Center team for getting us here today, and also a special thank you again to our Spaceflight Awareness honorees who are with us here today. I would like to introduce a space explorer himself. Bob Cabana, the Kennedy Space Center Director, the man responsible for the team that will bring Orion, the Space Launch Systems, everything to the launch pad so that we can fly in 2014 and 2017. Bob?
Thanks, Dan. Good morning and welcome to the Kennedy Space Center. I'd like to take a minute. We have many distinguished folks in the audience, but there's a few that I would like to recognize. First off, the Honorable Bill Nelson, United States Senator. The Honorable Thad Altman, Florida State Senator. Ms. Barbara Arthur from the office of Senator Nelson. Ms. Susan Fernandez from the office of the Honorable Marco Rubio, United States Senator. Mr. Patrick Gavin from the office of the Honorable Bill Posey, United States Representative. Mr. Jared Stout from the office of the Honorable Sandy Adams, United States Representative. Ms. Cindy Brown from the office of the Honorable Daniel Webster, U.S. Representative. We also have the rest of our Human Spaceflight Center directors here. Mike Coates from the Johnson Space Center. Mike's center is responsible for the program management that brought us Orion. Mr. Gene Goldman, director of the Marshall Space Flight Center. Gene's going to give us that rocket that's going to put this thing out of low Earth orbit. Mr. Patrick Sherman from the Stennis Space Flight Center. And Patrick's going to make sure that all those engines work on that rocket. And Brigadier General Anthony Cotton, commander of the 45th Space Wing and director of the Eastern Range at Patrick Air Force Base. General? You know, as KSC celebrates its 50th anniversary this month, I can't think of a more appropriate way to celebrate than by having the very first Orion multi-purpose crew vehicle here at KSC. Orion is ushering in a new era of space exploration beyond our home planet, enabling us to go further than we've ever gone before. The future is here, now. In the vehicle that we see here today, it's not a PowerPoint chart. It's a real spacecraft moving toward a test flight in 2014. It wouldn't be here today in this ONC high bay if it weren't for the outstanding partnership between the state of Florida, Space Florida, Lockheed Martin, and NASA. Thanks to all of you for the teamwork that brought Orion here. We still have many challenges in front of us, but I believe our future is bright. And as great as our last 50 years have been, I believe our next 50 years are going to be even better. We are going to continue the challenge of developing the innovative systems that allow us to explore beyond our home planet, while we enable the commercial sector to fly our crews and others to low Earth orbit in the International Space Station. Spaceports that were once science fiction will be reality. We are making that happen. My sincere congratulations to the Orion team that brought us this far, and I look forward with great anticipation to the first flight of Orion and your continued success. At this time, it's a real pleasure for me to introduce one of our strongest advocates, someone who needs no introduction, our Deputy NASA Administrator, Lori Garver.
Good morning. Thank you for being here. Thank you, Bob, and happy birthday to the Kennedy Space Center. It is a great day in Florida, and for 50 years, Kennedy Space Center has been our gateway to space. In fact, the road to space has always and always will lead right through the great state of Florida. With the delivery of this magnificent golden anniversary present, there is no doubt that, as poet Robert Frost once said, you still have promises to keep and many miles before you sleep. This is a milestone moment for the Space Coast, NASA, and America's space program. Orion's arrival here marks a major accomplishment in the ambitious new American space program that President Obama and Congress have approved. It's a new and exciting chapter in America's great space exploration story, one that will see more discoveries, more scientific return, and more people and Americans going into space and going places that have never before been visited. So it was just over 2 years ago in this very building that President Obama set a goal of sending humans farther into space than we have ever been, to an asteroid in 2025 and on to Mars in the 2030s. Our leadership in Washington agreed that the best way to do that was for NASA to work with the private sector to develop capabilities to transport our cargo and crew to the International Space Station and other low Earth orbit destinations, so that we at NASA, with our commercial partners, can continue to go further and to build America's next generation of space exploration system, the Orion spacecraft and the Space Launch System. So by investing with American companies and American ingenuity, we are spurring competition in our free market to give taxpayers more for their dollar, more bang for their buck, and while enabling NASA to do what it does best, also with our commercial partners, to reach again for the stars. We're, through this program, going to be ending the outsourcing of American space jobs and bringing them right back here to America and to Florida and to other states across the country. So this strategy is already producing tangible results, and the teams are here in Florida and across the nation are making steady progress. So in May, as was mentioned, SpaceX became the first private company to launch and dock a spacecraft to the International Space Station and return their capsule back safely to Earth. We have other competitors where we are looking to be doing this again more soon. But today, there's also proof that the strategy is working as we take this step with the Orion test flight in 2014. It will travel farther into space than any spacecraft designed for humans has flown in the 40 years since our astronauts went to the moon. But we do still have miles to go. Beginning today, this Orion capsule will undergo final construction and integration, supporting at least 350 additional Space Coast jobs. So you should all know that in our President's budget request for 2013, it includes over $100 million in investments in NASA's 21st Century Space Launch Complex program. We'll create new jobs in Florida and help modernize and transform the Kennedy Space Center launch infrastructure to benefit current and future government and commercial users. So NASA is a driver of innovation and economic growth, a creator of high-skilled, high-paying jobs, and a force for inspiration to the American people. Today, NASA and Kennedy Space Center are again lifting our sights and lifting our spirit to new heights. I want to again congratulate all of you at Kennedy Space Center and to those of you on the Orion team across the country, to our partners, Lockheed Martin, for achieving this historic milestone and getting us this far, putting us on a course, as you said, Bob, for greatness in the next 50 years. And it is my privilege to introduce someone who is helping us usher in these next 50 years. You hear a lot about dissension in Washington, but I'm here to tell you we work together well with our partners on Capitol Hill because Senator Bill Nelson has been one of the top congressional architects of this new strategy of the deep space program, of America continuing to lead in space. He is himself a former astronaut. He was talking about having spent time in these crew quarters not so long ago, but a great supporter of the Space Coast and one of the nation's best champions for NASA, Senator Bill Nelson.
It's good to be home, and I say that literally. Most of you do not know that my grandparents homesteaded under the Homestead Act when you, under the law, had to work the land for 4 years. They homesteaded a plot of 160 acres between 1913 and 1917. And that 160 acres is at the north end of today's Space Shuttle runway. I have a copy of the deed that's hanging in my office signed by President Woodrow Wilson to my grandparents. And literally, it was quite remarkable on that first morning, in that early morning darkness. I was the last member of the crew to climb in, and I wandered off on that launch pad by myself, looked in the direction only 3 miles away from pad 39A, where my grandparents had swatted mosquitoes and where they had fended off rattlesnakes and how they had dug out of the dirt a living. And I was amazed that they would not, were they living, could have believed that a grandson was literally going to leave the face of the earth almost right from the old homestead. It's also home, this very building, if you all recall, Hoot Gibson's crew, we spent a lot of time right up there because we had to go through 4 scrubs, still the dubious record, but on the 5th try, launched into an almost flawless mission. And isn't this beautiful? And I know there's a lot of people here that can't wait to get their hands and their fingers on this hardware. And ladies and gentlemen, we're going to Mars. Without question, the long-term goal of our space program, human space program right now, is the goal of going to Mars in the decade of the 2030s. We still need to refine how we're going to go there. We've got to develop a lot of technologies. We've got to figure out how and where we're going to stop along the way. And the President's goal is an asteroid in 2025. But we know that the Orion capsule is a critical part of the system that is going to take us there. And so we're working on it. And Kennedy Space Center workers are working on flight hardware that's going to fly. And who better to prepare Orion for this journey than the folks at the Kennedy Space Center? You think back, the tradition, the history of this place, every human spaceflight since Mercury, our country has entrusted the final preparation of the spacecraft to the Cape. The many Apollo spacecraft were tested and readied for flight right here in this building. When the Space Shuttle Columbia faced seemingly unsolvable technical problems, what happened? It was shipped from California, partially assembled, and it came here to KSC. And the agency knew that if any group of people in this world could get the revolutionary new spacecraft ready for its first flight, it was the folks here at the Cape. And when manufacturers struggled to build the elements of the International Space Station, perhaps the most complex engineering project in human history, once again, NASA called upon the Kennedy Space Center to finish the modules and ready them for flight. And now it's our time to put KSC's knowledge, skills, and experience to work on Orion, the spacecraft that will carry us farther than we've ever been before, the spacecraft that will take us to Mars. Ladies and gentlemen, the dream is alive. Thanks.
Thank you, Senator Nelson, and also thank you for all of your great support. At this time, we'd like to introduce members of 3 of our programs. Mark Geyer will come up and give you a summary of the Orion program. Dave Beaman will come up to talk about the Space Launch System, and Pepper Phillips will come up to talk about our ground systems in preparation for our launches. Mark?
Thank you. Thanks for coming today. You know, it's always an honor to be able to represent the Orion team. This piece of hardware behind me represents a couple of things that I'd like to talk about. First of all is this incredible test we're about to do in 2014. I'll talk about some of the specifics, but as Lori said, it's going to go much further than we've gone in a very long time and exercise some of our key systems. But to me, it also represents the incredible dedication of the Exploration Systems team and the Orion team. Folks working nights, weekends, holidays to get this hardware here to meet the schedule that we're trying to meet, and actually trailing a tropical storm to get it here on time. So incredible work by the team. But I think that's just an example of all the stuff that these guys are doing every day. And also, again, I also recognize the spaceflight awareness folks that are here today also in their great work that keep us moving forward. I'm going to show some pictures because EFT1 is our next milestone, but it's not the first. And we've done a lot of great work so far and leading up to keeping America first in exploration. So I think this will work. There we go. A couple years ago, we did a pad abort test out at White Sands Missile Range in New Mexico. The pad abort test is important because during all phases of flight, we want to be sure that if we have issues on our systems that we get the crew safely home. One of the most dynamic phases of flight is early in ascent. And so we have a system that will get the crew off, even in that very difficult phase of flight. It's a very energetic phase of flight. That's why we did that test first. It's the highest loads. The vehicle is going to see some of the most critical commanding and operations that need to be done. And an example of that is an attitude control motor that has 7,000 pounds of thrust. It's a solid rocket motor. The valves themselves see 3,000 degrees temperature and have to operate in those conditions. The flight worked flawlessly. And again, it's just another example of the many tests we are using to move forward to putting people into space. The heat shield structure, which will eventually come here, is being fabricated in Denver. Then it'll go to Connecticut, and we'll actually add the thermal protection system and then ship it down here to Florida. So another key part of the Orion system coming together. One of the most stressing things the vehicle will see is the acoustic levels. These are the sound levels we'll see from the launch of the rocket or an abort if we have to do an abort. So we've actually manufactured a ground test article that you can see further down in the ONC. We put it through its paces in an acoustic chamber at Lockheed, also did some random vibration testing. All of this is to make sure that we understand how the structure is going to behave, how the systems are going to behave in real flight. So another key test for Orion that we have successfully completed. Parachutes are another critical system. It's one of the few systems that actually assembled itself during operations. We have several parachute pieces, drogues, pilots, mains. So we do several drop tests out at Yuma to test to make sure the system will work properly. This is an example of two different tests where we change the different reefing, how we open the parachutes. And we have a mock-up of the Orion. Here you see it coming out of the C-17, so we can model the wake, how the aerodynamics behave and how the parachutes behave when they open. A lot of things, again, moving forward to flight. We do a lot of testing of our thermal protection system. We did a lot of early development in the Orion program to figure out which was the appropriate thermal protection material. Now we're testing the specific environments we're going to see in flight. And now we're actually putting in test modules of the instrumentation we're going to put on EFT-1. All, again, to make sure we understand the environments and have the right design when we actually put the people on board. Also, I think it's important to note that one of the things the exploration systems provide not only is the hardware to fly, but we provide this information on heat shield material, parachutes, aerodynamic databases, landing studies that we've done. We provide that to the commercial providers who are working commercial crew transport to space, so they don't have to recreate this information. So as taxpayers, it's a great value. It's kind of a spin-off in my mind, providing expertise and technology to help them move forward. We do a lot of wind tunnel testing. This is a wind tunnel test of the drogue parachute deployment. And then we do a lot of landing tests. Landing, it turns out to be the most stressing load case for the primary structure that you see behind me. So we have models that do a pretty good job, but there's uncertainty in how water reacts with the primary structure. So we did testing at Langley. We have this system that allows us to test by changing the velocities and the angle of the unit. We can test different wave heights, all the kind of different environments we might see. So great work by the team at Langley. And we'll take this ground test article. You'll see further down, we'll put a real heat shield on it. We'll be dropping that in about a year. I mentioned before that we have a case that we can abort. We can get the crew off during launch. There's also aborts when we're out in deep space, where potentially you could have a depress event. So the crew needs to be in their pressure suits and they need to stay in there for a while so we can keep alive as we bring them back to Earth. One of the things we're uncertain about is the suit inflates. Can they get back in their seat? Can they do the other operations? So at JSC, we're actually doing tests even today on pressurizing these suits and moving them around in a cabin and doing tests with the seats that we've designed for Orion. Again, all these important pieces that it takes to get a full human-rated system. That's actually Rex Walheim there hanging from that cord. Of course, mission operations will be part of when we fly people, and they'll actually be part of EFT-1. There's a few contingency commands we can send during that flight, again, to flesh out the integrated system. So we've already actually had some tests from our avionics lab to mission operations at JSC, and it worked great. It's hard to have exciting pictures of avionics, you know, flashing red lights maybe, but this is for an avionics guy. This is pretty exciting stuff. This is the lab out in Denver. We have the brass board units out there for the main computer, the networks, the power distribution units, so all the engineering units are starting to show up. And on the upper right is a picture of the power distribution unit, which is really an integration marvel. Great work by the Lockheed team there. More testing of the seat interface with the crew displays. This is a picture of the Pad Abort 1 crew module. We reuse a lot of the hardware that we do for our testing. So after this test, we actually brought it here to the KSC to do some mock-up and work out some other operations. We've also used it for some of the public relations events that we've had. We had a mock-up here actually in Florida, took it out in the water, had the search and rescue guys participate in testing there to make sure that we had the right fittings, how we would get the crew out when they landed. So a lot of good work there. All these, again, a lot of different tests to move forward to flight. This is a picture of the building you're in. And I think, as was mentioned before, the exciting part about this building is we're actually assembling the vehicle here in Florida. And the guys, as was said before, can't wait to get their hands on this thing and start moving forward. There's a lot of subtle things about how this is such an adaptable factory, allows us to move tooling around to adapt to the changing requirements as necessary, and also to have the clean room effect as needed. And you can see the HEPA filters behind me that allow us to have the cleanliness we need to install some of the life support systems. Again, lots of public relations, getting out, telling the folks that Orion and Exploration Systems is part of how NASA is moving forward to stay in exploration, stay a leader in exploration. There's a better picture of that right behind me than the one on the screen. So EFT-1, as was mentioned, is going to go 3,000 nautical miles into space, over 10 times higher than the space station orbit. We're going to get about 84% of a lunar entry velocity, which is really going to stress the heat shield, which is exactly what we're trying to do. We'll also exercise key deployments of fairings and separation of the crew module and service module. We'll also test the guidance and navigation, and we'll do a nominal recovery off the coast of California. So there's a lot of things we're exercising, including interfaces with SLS. They're building an adapter for us as part of this test. So a lot of things we're doing, not just for Orion, but for the whole exploration system. So EFT-1 is the next step. Beyond that is the more exciting stuff. Beyond that is also flying in 2017 on Space Launch System, and so David Beaman's going to talk about that next.
As I sat here and thought about everything that's happened in this building over the years, I'm in awe. You know, I think about what we're doing with SLS and with Orion, and I looked at the people that are discussing this, and I finally realized why I was asked to come down here. You have really dynamic speakers up front to start a program, and really dynamic speakers in the end, and then you have fill-in people. And so I'm a fill-in person, but I'm okay with that. Exploration. I guess I'm going backwards. Why are we here? You know, you look at SLS, you look at Orion, it's our desire to explore. If we look all the way back, the history of our country, we have a desire to go places that no one else has gone, to experience things that no one else has experienced. You know, that's amazing. If we think about how it actually looks out there, what it would be like to be in space. Well, we at SLS are only a portion of that overall vision, and we're providing the capability to go deeper into space. Now, if you look at our mission and our vision, there's different pieces to that from an agency and from a program. We have strategic partnerships with the commercial industry to do what we did previously with the shuttle and provide people in cargo access to low Earth orbit. Our goal for SLS is to provide that access deeper into space and to do those things that we've only really thought about to this point. So if you look, this is an amazing rocket. You think about the size, you compare it to a Saturn V or the shuttle, absolutely amazing. The biggest rocket the world has ever considered. We're designing it, building it, and in a few years we're going to be assembling it down here and flying it, and that's exciting. If you think about the heritage hardware, the fact that we have a strategic approach at the agency level to utilize existing heritage hardware as well as develop future hardware, what we're doing is strategically managing our assets and doing things that are most effective for the agency. You look at the SSMEs, the fact that they'll be used, or we call them the RS-25s, early in the program, then we'll have potentially other engines developed. That's amazing. If you look at the solid rocket boosters, the heritage from the shuttle, taking that, stretching it to a 5-segment, actually utilizing some of the margin tests from that program. That's amazing. Continued hardware development in not only the motor and booster worlds, but in the SSME world for future missions. You know, you see some of the asteroid structures that are being used out at ATK. Look at some of the testing that's happened early in the program. You think about the J2X, the development. Actually, the first engine developed in over the last 30 years in this country. That's amazing progress. Think about the testing. You look at Stennis Space Center, all the testing we've done down there, the design work at Marshall. All of that will come together and will be integrated here at Kennedy Space Center for our first mission. The avionics work. Mark talked about the avionics. We have an avionics system on the SLS, and that's going to have to integrate with Orion and other areas. There's been a significant amount of development work done in the avionics world. and these pictures represent that. One thing I'm proud of is our office. We have a strategic partnership with Orion to provide some hardware for EFT-1, the actual physical adapter. My office is responsible for designing and building and providing that for EFT-1 to fly on the Delta IV. And we're actually designing and building that in-house at Marshall. Then it'll be shipped down here and integrated. So it's a strategic partnership to where, you know, now we're not off designing things in different programs and then realizing we overlapped. We're actually partnering, doing it one time, doing it right, and then we'll build it multiple times. Part of that, we're utilizing the friction stir welding. You see the facility here, similar to what's being used with the Orion capsule also. And obviously the development, you look at modeling that we have to do wind tunnel testing. This shows basically a 3% wind tunnel model. This is the hardware I spoke about earlier. This is an ingot, and we're actually machining the parts at Marshall Space Flight Center right now, and we'll be doing the friction stir welding of the panels in order to have our Pathfinder, and then we'll be building the flight hardware real soon. And this is actually in the 7-axis machine at Marshall. Technician actually doing the programming work. The one thing I like is they're excited, the young engineers. When you get to do design work, build things, young engineers get excited and they don't just feel like they're following somebody else's work. The MSA, or the adapter that I talked about for the Orion vehicle that we're providing, is noted on this picture. And this is the ingot. That's a pretty big hunk of metal. You know, if you think about the capsule, you think about the size. This is actually up at lattice. This is the ring that will be used to make the first flight adapter that will mate to the capsule that you see behind us. And this is the actual machining that was done at Marshall on that Pathfinder. So you look at the rocket, you look at the aggressive schedule that we have, you look at the development, the sharing among centers, the core stage development and work at MAF, the integration work here at KSC, the engine work at Stennis, design work at Marshall. It's truly a teaming environment. And I'm proud to be a part of it, Mark. I'm proud of the opportunity to participate and provide something for y'all. And, you know, it's just an amazing team, and we thank you for that opportunity. So if you look from a heritage standpoint, you see the old Saturn V on the left. You see the shuttle, which was our present up until last year. And now you look at SLS, and that's our future launch vehicle. So with that, thanks for the opportunity, and I'd like to introduce Pepper Phillips.
Well, let's see, if that didn't excite you, this really will excite you. We're building big hardware here at KSC. I know Lori had mentioned we're transforming KSC, which is in fact what you'll see around here as you make your way around the center. You'll see that transformation. I'm going to share with you some actual hardware that you can really get your teeth into, that you'll see, big items at the center. We're doing that, but we're doing it in a transformation that has never occurred at Kennedy Space Center before. Of course, KSC has a long heritage of being able to build ground systems supporting NASA missions. We're now venturing beyond that. We're getting into missions that reach out to commercial users and other government entities. So I'm going to tell you a little bit about how we're doing that in subsequent slides. So this is kind of an image that tells you a little bit what that plan is. Of course, we're going to keep our eye on the ball. We're going to make SLS and Orion successful. We're going to be ready in 2017 when the flight hardware arrives. But you'll see in the background there that we're also keeping our eye towards the commercial community. That's bigger than what KSC has historically done. We're excited about it. It's an enabler for both SLS and Orion and low Earth orbit capabilities that the commercial industry is pursuing. So what you'll see here is our flight hardware. This is the work that's being done at KSC. This image was done about this time last year. What this shows is the lightning protection system out at Pad B. What you'll see there is the heritage equipment from Shuttle, which is your FSS and RSS. And in a before and after picture, this is the same pad minus the FSS and RSS. So what we're doing here is moving to a clean pad approach. Told you I'd mention a little bit about how we're evolving so we're also adaptable to more than just the SLS and Orion. This clean pad approach allows us to interface with more than one vehicle potentially. So it's not specific about the pad. You have all your services at the pad in this environment. You got your fluids, you got your power. But a vehicle can come in any shape and size, and we'll be able to launch from this incredible pad and be able to hook up to it just like any other vehicle would. And that's our intent when we go design these systems. What you don't see here is a lot of other work that's going on at the pad. Things like refurbishing the water tower so the sound suppression system's ready to go. You've got other systems beneath the pad, which is your power and electrical. All of that is the development work that you don't see readily, but it's work that's going on here at KSC. This is our mobile launcher for SLS. It's repurposed from Constellation. We actually did a study and said, can we in fact use this existing hardware in order to execute the SLS mission? So giving the parameters and working with our SLS friends, we did an assessment that said, yes, in fact, we can repurpose this hardware. So that's what we've got. We've got a structure that was completed in 2010. We've run a couple of tests with that structure since building it. We actually had a dynamic test for us. This is our mile-an-hour check, 1 mile per hour run out to the pad. We actually instrumented this with a bunch of strain gauges to go check the structural response of this item, again, like Mark mentioned, to validate some of the models that we had in building this structure. And once we got to the pad, we did the alignment checks, again, to check our engineering. How good did we do when we got to building this equipment, and how did it fit with the pad? What I'm happy to report is test results said we're pretty dang good at this. Back in the VAB, this is our crawler transporter 2. This will be, and we're using single string assets to go execute SLS and Orion. Crawler transporter 2 will be our crawler for SLS. What crawler transporter 2 is not capable of doing is lifting that much weight. The combined mobile launcher with the SLS and Orion is heavier than the capability of this current transporter. So we're making modifications and upgrades to this transporter in order to enable it to lift that weight. Also in here, you got to realize we have a 45-year-old piece of equipment. So with a 45-year-old piece of equipment, it's time to modernize some of the controls, etc., hydraulics, power, comm systems on this crawler transporter, and that's in fact what we're doing now. Again, here's another image of that same crawler transporter. We changed out a couple of the generators in the vehicle. It's a 750 kW generators that were powering the trucks. We're going to a larger capacity capability, should be 1,500 kW. So these are 2 of the existing units coming out. We put 2 new ones. They're already installed. This is a picture inside the VAB. It's just an illustration of some of the work that we're all pursuing. Again, maybe not that exciting looking at. It's cables. What I'll tell you is we've got 45 years worth of cable installations that have gone on inside that vehicle assembly building. So you'll see a lot of cables on top of cables. Some were terminated in place in order not to have to replace a bunch. What you'll see is old style cables. What we're doing with those is pulling those out and putting in real small fiber optic cables that are consistent with what we're doing now. That's representative of what else is going on in a 45-year-old building. You know, it's got plumbing requirements, it's got fire X things that need to be changed out. It has comm systems that need to be updated. We're doing all of that in this downtime cycle before we are up and running with SLS and Orion. Wanted to reacquaint you with what we have inside High Bay 3, which is the existing platform set for shuttle. Incidentally, the platform set that we use for shuttle was migrated from Apollo. These are ganged platforms. In other words, there's more than one access point for each of those platform sets. This is where we get into being able to transform beyond what is a unique or specific vehicle. In a gang platform set, when you go up against a vehicle, you got what you got when you go to access it. What we've done with our proposal and our future designs is what you see here. And again, this, to orient you, this is a cutaway This shows one side of the high bay. The service tower is towards the door, so that would be the east side of the building. But what those platform designs are telling us is we're going to have an individual platform set that is reconfigurable to a different vehicle. In fact, we want to go do that. Those platforms translate back and forth, but they can be repositioned so to change with different heights of the vehicle. And they also have inserts that you put in the platforms themselves. So the vehicle shape, so the outer mold line changes on a vehicle. This particular high bay and this development effort will allow us to gravitate with the changes in the outer mold line. Again, here's a picture with the SLS and Orion. And this is where we ultimately hope to get to. This is what we expect to see in 2017 with our new mobile launcher, reconfigured, rebuilt. We are going to have to modify that existing structure in order to be compatible with the SLS and Orion, but that's our in-state plan. Back in the LCC, not like Mark mentioned with the Mission Control Center, we too are going through a transformation. This control center was modified again for Constellation and was in fact used for the Ares 1X. It was used with the existing systems at KSC. We are in fact going through a redesign of that system. Spaceport Command Control communication system is what we're building now. It's to be compatible with more than one launch vehicle. So that's where we're heading. You see here, we're using a lot of the existing COTS, commercial off-the-shelf enclosures for the equipment, and we're going to have some very modernized displays in this control room. And finally, as Mark had mentioned, our teams have been working well together to get ready for this guy and for EFT-1. Part of what we've been doing is going out and running the test in open water, looking for opportunities to inform the design and make this recovery effort as smooth as they can be. So we're on task to do that. We look forward to be the first to greet EFT-1 and Orion when she returns. And with that, Dan, I guess I'll turn it back to you.
Thank you, Pepper. Thank you, Dave. Thank you, Mark. As you can see, lots of excellent progress. The team has really been working great, and it takes a big team to go do this. Our industry partners are critical to our success. So for Orion, I'd like to introduce Mr. John Karras from Lockheed Martin.
Well, first of all, I want to thank everybody for being here. It's a wonderful day, the new home of Orion. And thank you for your interest, but I want to thank some other folks here. You can't have this event without a lot of teamwork, not just for building the spacecraft, but working together to make an event like this happen. So I want to thank NASA headquarters for hosting this and supporting what we're doing here and providing us a wonderful vision of Orion and SLS and going to a NEO and Mars and beyond, so I appreciate that. And KSC for hosting this wonderful event on their premises and in the building here and providing the ground systems for, for everything that we're doing, whether it's Orion or SLS. And of course for JSC support. Of course we talk a lot about production, but of course the engineering gets done by some wonderful folks, not only just on the industry team, but also our partners at JSC. And of course, Marshall providing a ride when we go beyond low Earth orbit. But, and of course, our speaker, Senator Nelson, you've always been a great supporter, and I appreciate it. And this is just the start of a lot of great things that will happen here in Florida. And of course, I want to thank the SFA awardees for being here and being able to transition from shuttle experiences and help into Orion and the next generation of explorers. But this day, today is a day of firsts and remembrances. And let me give you a personal remembrance. I first started working here at KSC, yes, as a NASA cat, way back when, in January of '75. Little grayer, but I worked Apollo Soyuz. It was a wonderful thing, and I swore that I always wanted to be around, see the next generation of spacecraft to go beyond low Earth orbit. And personally, I'm just thrilled to be standing in front of the spacecraft that's going to enable us to do that. So if you work long enough, not only does it excite old engineers, young engineers excites older engineers too. And so I appreciate to have that opportunity. Now, at a larger scale, Lockheed Martin is also celebrating its 100th anniversary, its centennial. In a tribute to our founders, Glenn L. Martin and Malcolm Lockheed, they started in a church and a garage, respectively. Now, I got to say, we've been upgraded a little bit in this facility, and it is just a wonderful capability we have today, reaching back to the heritage of Apollo, but yet outfitted for the next generation of spacecraft. So we'll be celebrating our centennial. Lockheed Martin will be throughout the year, and the achievements of our customers that we've worked together, and of course look forward to working on Orion in the future. Likewise, this year in February, our nation celebrated the 50th anniversary of the first orbital flight. And of course, Lockheed Martin Heritage Atlas contributed to that success, and since then we've been proud partners with NASA in the human spaceflight world. And so we just can't wait to go beyond low Earth orbit. And of course, yesterday, July the 1st, in 1962, NASA activated their Launch Ops Center, now known as KSC. So a lot have passed, but today we're here to celebrate our nation's next generation deep space human exploration vehicle, and the first of any kind manufactured in Florida. So now we're operating the vehicle out of here. It will be finished and completed and tested and operated in this building as well. So many firsts, and really a great tribute, as Senator Nelson said, to the folks here in Florida to be able to do that. Orion will carry humans, of course, on top of SLS, to destinations never explored. The missions will undoubtedly change the way we see our solar system and the way we see ourselves here on Earth. Seeing Orion's structure behind me today makes me proud of many of our teams and people working this, but I'd be remiss if I didn't thank the hundreds of men and women at Michoud in New Orleans, and of course here in Florida for getting the vehicle here on time. And there's people ready with drill bits and tubes and pipes ready to start assembling this vehicle as soon as we're out of here and out of their way. So, no. But it's just have to thank everybody that makes this possible. And likewise, I'd like to thank the NRO and ULA this past Friday for our Delta IV test flight that they had. Of course, they put up a national security payload, but our test flight for EFT-1, of course, it flew the ICPS that's going to fly on SLS. And it'll be the next, EFT will be the next Delta IV Heavy that's flown out of the Cape. So many things are going on getting ready for EFT-1. And the next 18 months will be no exception. Here in the ONC, we have many things to do, and there'll be many firsts that we'll do in this building. So I look forward to having you back here when we have other firsts, like when we power up the spacecraft and we complete most of the assembly and made it to the SM. But in the meantime, there's just so many things to be proud of and to look forward to as a great nation, space exploration nation. And I just can't wait to go beyond LEO. When I saw the last Apollo-Soyuz fly, you know, it was wonderful. But I can't wait to see Orion fly and take us deeper into the cosmos. Thank you very much.
Thank you, John. And there you have it. This country has gone to the moon on Apollo. We have built the International Space Station with the Space Shuttle. We are now servicing or beginning to service the space station with our commercial partners. And now behind us, you see the first step to go beyond low Earth orbit. Exploration Flight Test 1, you will now see a video of the next step, and the Orion Exploration Flight Test is our first step on to Mars.